Hi, good morning to everyone. In this session, we have to discuss about definition and preparation methods of nanomaterials. So, nanomaterials. What is meant by nanomaterials? These are the chemical substances that are manufactured in nanoscale. That means 10 power minus 9 scale. That means these materials are having their dimensions in the range of 1 to 100 nanometer. That both internal and external structures may have this scale, that is the nanomaterials. So nowadays these development of nanomaterials are having great attention because of their increased strength, chemical reactivity and conductivity. So next we have to see about synthesis method. So first one, Solgel method. This is one of the method to synthesize nanomaterials. In this method we are using organometallic compounds, mostly metal alkoxides. Then metal nitrates, metal chlorides are used as a precursors. We are conducting this preparation method in aqueous medium, and in this reaction, that hydrolysis and condensation of precursor can be taken place. It results in the formation of the gel. That gel undergoes further in the process of aging, solvent extraction, and then finally it has been dried to get solid product. So these reactions can be catalyzed by either acid or base. If you use acid, and then we can get dense networks. If you use base, we may get diffused networks. So these hydrolysis reactions have been taken place, so that a rate of hydrolysis reaction can be altered by changing the acid or a base as a catalyst. So during the gelation, the condensation reactions between the precursors results in the formation of the gel. That gel further undergoes hydrolysis as well as polymerization. These reactions can be taken place in aqueous media, that means alcohol or a water media. So next we have to apply that Solgel method to synthesize silica nanoparticles. So in these silica nanoparticles, we are taking TUOS, that means tetraethyl orthosilicate, as a precursor. So this precursor undergoes hydrolysis and polycondensation. So first, initially we have to mix this TUOS with water in the ratio of 4:1. That means 4%, 4:1. Next, after mixing, hydration will be taken place, and first TUOS was hydrolyzed and it is converted into silicic acid as equation 1. That means hydration of the TUOS. This is the TUOS. So hydration of this TUOS results in the formation of silicic acid. Then a condensation of this silicic acid further taken place and results in the formation of SiO2. That means SiOSi, silica oxygen silica bond. So overall reactions employed in this method is called as a Solgel method. The reactions is given here. So what are the advantages? So these reactions can be carried out in room temperature, and we can prepare novel materials, functional materials with potential applications in different fields. So when we compare this other method, this method is very attractive and it is very cost effective, and we can synthesize nanoparticles with different morphologies like nanofibers, powders, nanofilms, etc. Next one is Micellar method. So in this Micellar method, we are mixing two non-miscible materials in the presence of surfactants. That means we are taking two non-miscible materials, then we are adding surfactants. These surfactants connects these two non-miscible materials together. After that, collision of these non-miscible substances taken place, then reaction between them can be taken place. The reaction may be hydrolysis or condensation. Then results in the formation of the nanoparticles. So this is the method, Micellar method. So here that scheme is represented. So A and B, consider A and B are the precursors. They are non-miscible together. Even if you mix also, they won't mix together. For example, oil in water. So both of the things cannot be mixed together. So to mix both of them, we need some surfactants. So I told as a examples, I say not in a oil or a water. That means one of the mixture is hydrophobic in nature, another one is hydrophilic nature. Both are not having mixed together. So now we have to add a surfactant to mix both of them. So in the presence of surfactant, both of A and B will be collide together and they will form a dimer droplets. During these dimer droplets, these two materials undergoes condensation or hydrolysis some reactions. After they may be integrated into single droplets. So these single droplets results in the formation of nanomaterials. That means the resulting nano droplets undergoes nucleation, growth, ripening, and coagulation of primary particles, and these results in the formation of nanoparticles. These nanoparticles are surrounded by water or a stabilized surfactants. So now we have to apply that Micellar method to synthesize zinc oxide nanoparticles. So here we are taking C-tab as a surfactant. That means cetyl, trimethyl ammonium bromide and 1-butanol and isooctane. This mixture can be used as a surfactant here. So we are taking zinc metal and in the concentration of 0.1 molar, and we are mixing the zinc inside this surfactant, and we are getting transparent solution. Thereby we are again taking C-tab 1-butanol isooctane surfactant. In that we are taking oxalate in the concentration of 0.1 molar, and again we are mixing and we are getting transparent solution. Both of the solutions have mixed together now slowly, and then we have to keep this up to overnight. After that droplet dimers will be formed between these and these. After that, hydrolysis and polycondensations will be taken place and results in the formation of nano droplets. So that nano droplets further undergoes some reactions and then results in the formation of solid nanomaterials. So these solid nanomaterials should be centrifuged and washed. After that washing is very important to remove that excess deposition of surfactant as well as other materials present in that mixture. Then resulting resulting nanomaterials are calcined at 450 degrees centigrade. So during that calcination, we are getting a zinc oxide nano powder. So this is the important thing.